Have you ever looked up at the night sky? You see stars, maybe a planet, perhaps the faint streak of a satellite. But some things are designed never to be seen. They move through the darkness like a phantom, a whisper on the wind. The B-2 Spirit bomber is one such creation. A marvel of human ingenuity, a flying wing that seems to defy what an airplane should look like. It has no tail, no distinct body. A smooth, dark, boomerang-shaped craft slicing through the atmosphere with an eerie silence, hiding immense power. It's more than an aircraft, it's a statement. A testament to bending the laws of physics and hiding in plain sight. This machine is a ghost, designed to slip past the most advanced eyes and ears nations can build. Radar, the electronic sentinel of borders, is rendered almost blind by the B-2. It can travel vast distances, crossing oceans and continents. It can carry a payload capable of changing history in a single mission. Yet it's incredibly rare. Only 21 were built, and after a tragic accident, only 20 remain. Think about that. In a world of billions, only a handful of these specters exist. Why so few? To understand the B-2, we must travel back in time. Journey with me to the latter half of the 20th century. The world was a different place. It was split in two, divided by an iron curtain. On one side stood the United States and its allies, on the other, the Soviet Union. This was the Cold War. It was a time of suspicion, of espionage, and of an arms race that pushed technology to its absolute limits. Both sides built vast arsenals of nuclear weapons, enough to destroy the world many times over. The strategy was called mutually assured destruction. It was a terrifying balance of power, held in check by the threat of total annihilation. In this high-stakes chess game, the ability to strike first, or to survive a first strike and retaliate, was everything. The United States needed an aircraft that could do the impossible. It needed a bomber that could take off from American soil, fly thousands of miles across the globe, penetrate the most heavily defended airspace on the planet, and deliver its payload without ever being detected. The Soviet Union had invested heavily in a sophisticated network of early warning radars and surface-to-air missiles. Getting past this defense was the ultimate challenge. How do you make a massive 400,000-pound machine invisible? The answer starts with its shape. Look at the B-2. It's unlike almost any other aircraft. This is not for style. Every curve, every angle has a single purpose: to defeat radar. Radar works by sending out radio waves and listening for the echoes that bounce back. A conventional airplane with its flat tail fins, sharp wing edges, cylindrical body, is like a hall of mirrors for radar waves. It bounces them straight back to the receiver, announcing its presence loud and clear. The B-2, however, is designed to do the exact opposite. The B-2's design is called a flying wing. Pioneered by Jack Northrop decades earlier, finally perfected for the stealth mission, it has no vertical tail fins. The leading edges of the wings are angled to deflect radar away from the source like skipping a stone across a pond. The surfaces are smoothly blended, with no sharp corners or protrusions. Even the engines are buried deep within the thick wing structure, intakes and exhausts carefully shielded to hide them from radar and heat-seeking sensors. The B-2's radical shape is only part of its stealthy magic. The other, equally important part is the secret sauce, the advanced materials that make up its skin. The aircraft isn't just made of ordinary aluminum. Its surface is a composite cocktail, a carefully engineered blend of carbon graphite materials, special coatings designed to absorb radar energy. Instead of deflecting radar like a mirror, the B-2's skin soaks it up like a sponge. Radar waves hit the surface and their energy turns into a tiny amount of heat that dissipates across the aircraft, never returning to the radar receiver. This is radar-absorbent material, RAM, a family of top-secret substances fundamental to stealth technology. These aren't simple paints, they are complex, multi-layered composites applied with incredible precision. Even a tiny gap, a loose screw, a poorly sealed panel can create a radar hotspot. That's why the B-2 needs meticulous, expensive maintenance. Maintaining this delicate skin is monumental. B-2s live in climate-controlled hangars. After each flight, teams of technicians inspect every inch. They scan for delamination cracks, imperfections in the RAM coatings. Any damage, no matter how small, must be repaired. That can mean stripping the damaged area. So, if the B-2 is so amazing, why not just fire up the factory and build a new fleet? Well, the problem is the factory no longer exists. The B-2 was built by Northrop Grumman at a specialized plant in Palmdale, California. This wasn't just any assembly line. It was a unique ecosystem of custom-built tools, specialized machinery, and a highly skilled workforce. These were artisans of the aerospace world, people who had spent years, even decades, mastering complex techniques. They knew how to handle the fragile ram, how to bond composite structures with microscopic precision, and how to integrate thousands of secret components. When the B-2 program was cut from 132 aircraft to just 21, the economic reality was stark. It wasn't feasible to keep that industrial infrastructure running. The specialized tooling and jigs were ordered destroyed. That saved storage costs and acted as a security measure to keep the tech out of the wrong hands. The blueprints may exist, but the physical tools are gone. Even more critical is the lost human capital. Engineers, technicians, assembly workers, many retired or moved on. Their tribal knowledge wasn't always written down. It came from years of solving unexpected problems on the factory floor, knowing exactly how much pressure to apply when bonding a panel, or how to spot a subtle flaw in a stealth coating. Let's talk about the universe of numbers. Some are so large they are difficult to comprehend. The cost of the B-2 bomber is one of them. When the program was first conceived, the idea was to build a large fleet, which would spread the enormous research and development costs across many aircraft. But as the Soviet Union crumbled and the Cold War ended, the justification for a fleet of 132 bombers evaporated. The order was slashed to just 21. This had a dramatic effect on the price tag of each plane. All those billions spent on design, testing, tooling now had to be divided by a much smaller number. The result was the most expensive aircraft ever built. In the late 1990s, the average flyaway cost for a single B-2 was around $737 million. But that's not the whole story. When you factor in the total program cost, including development testing facilities, the price per aircraft skyrockets to an astonishing $2.1 billion. Let that sink in for a second. For the price of one B-2 bomber, you could build a dozen major hospitals or fund a space mission to Mars. The universe is in constant motion, and so are the priorities of nations. After the fall of the Berlin Wall in 1989, the strategic landscape changed forever. The United States military found itself in a new era. The singular existential threat of the Soviet Union was gone. Regional conflicts, Iraq, regional conflicts, the Balkans, the rise of non-state actors and groups like Al-Qaeda, the growing need for flexible, rapid response capabilities. Defense spending had to adapt. The case for a massive fleet of ultra-expensive, single-purpose B-2s got harder to make. The military needed different tools, precision-guided munitions, intelligence and surveillance platforms, drones, enhanced special operations forces, cybersecurity defenses. A single B-2 costing over $2 billion. That could buy an entire fleet of Predator drones, or fund training and equipment for thousands of soldiers. Lawmakers and planners faced tough budget choices. The B-2's combat debut, Kosovo, 1999, later missions over Afghanistan, later missions over Iraq, a record-breaking 44-hour round trip from Missouri, a display of global reach. Those missions proved the bomber's value. Time marches on. Technology evolves. Even the most advanced machine of one generation is eventually surpassed by the next. The story of the B-2 is now entering a new chapter, one that involves its successor, the B-21 Raider. The B-21 is the culmination of everything the Air Force learned from the B-2 program, both its triumphs and its challenges. It is designed to perform a similar mission, a long-range, penetrating stealth bomber capable of holding any target at risk. But it is being developed with a completely different philosophy, one shaped by the lessons of the B-2's astronomical cost and maintenance burden. The B-21, while visually similar to the B-2 with its flying wing design, is expected to be slightly smaller. More importantly, it is being designed from the ground up for affordability and sustainability. The goal is not just to build a capable aircraft, but to build one that can be produced in greater numbers and operated at a lower cost. Planners are aiming for a fleet of at least 100 Raiders. This involves using more modern modular manufacturing techniques, open architecture electronics that can be easily upgraded, more durable stealth materials that don't require the same level of intensive, depot-level care as the B-2's delicate skin. Think of the B-2 as a hand-built, bespoke luxury car. It's a masterpiece of engineering, but it's temperamental and incredibly expensive to maintain. The B-21, by contrast, is being designed more like a high-end, mass-produced performance car. It leverages the latest manufacturing technologies like advanced robotics and digital engineering to make the production process more efficient and repeatable. The focus is on creating a digital twin of the aircraft, a virtual model that allows engineers to test and refine the design before any metal is ever cut. So, we find ourselves back where we started, looking up at the sky. The B-2 Spirit remains a singular marvel. It is a ghost from another era, a relic of the Cold War. It still casts a long shadow over the present. We can't build more of them because the world that created them is gone. The factories have been dismantled, the tools destroyed, the artisans have moved on. The strategic calculus has fundamentally changed. The sheer cost, born of a time of existential conflict, is something our current world is unwilling and perhaps unable to bear for an old design. We are looking to the future, to the next generation of technology embodied by the B-21 Raider. Yet, the B-2 story is far from over. For the foreseeable future, the 20 remaining bombers will continue to be the crown jewels of America's long-range strike capability. There is still nothing else in the world quite like them. They represent a unique power, project force anywhere on the planet, at any time, without being seen. This capability provides the United States with a powerful diplomatic and military tool. The mere presence of a B-2 in a region sends an unmistakable message, a silent but potent signal of resolve and strength that can shape the decisions of allies and adversaries alike. The legacy of the B-2 is more than just the aircraft itself. It is in the decades of scientific and engineering progress it spurred. Advances in composite materials, fly-by-wire flight controls, computational fluid dynamics, stealth technology. Its legacy carved not in stone, but in the very fabric of the sky itself.